Welcome to Sa Majesty Easy World Science Channel. So today we'll be handling the alternative to practical physics. The alternative to practical physics, you just need to deal with measurements to measure accurately. Considering this here, the first question is on simple pendulum. They gave you the instructions. They tell you to show the raw values y1 and also show the corresponding values y1 to 2. So you are going to make a table according to the instructions. This is a normal simple pendulum, we all know. So see the bulb is there. This is the bulb, then the thread, so we use a highlighter. This thread will have different lengths, of which they gave us in the image. You are going to measure the raw, which is what you found in the paper. So we'll go to that question immediately. So over here, you just need to measure these things then and multiply by the scale given. That's what we're going to do. So these lines, you have to use your ruler, but this is soft copy. There is no way we can measure accurately, but I've measured these things real life, as you can see down the screen. Then you are required also to know the time. For y1, you take a look at the reading for this is t1, which is checking this. You see, here is 28.6 and here is 28.8, which means the distance from here to here is 0.2. It's just 0.2, so the middle will be 0.1, so this should be 28.7. For t1 should be 28.7, and then for y1, which will bear that of the t1 actually. So this y1 have the time. I've measured this real life. This one reads actually 6.1 cm, of which I have to multiply by the scale. The scale told you that 1 cm that you get from the paper is equal to 10 cm in real life. So this one is the raw. You have to get y1 raw and get y1 in the reality. So which means 6.1 should automatically be what? So 6.1 should be, when you multiply 6.1 by 10, you will get nothing but 6.1 multiplied by 10 should be 60. So that's going to be your real. Then you take the time. For y2, I measured in real life. I got 7.1, if I can remember correctly, which if you multiply by 10, you will get 71. So to make you understand this, you need to have a table of which I have made already. So this table, I will fill in the values I have measured already according to what is there. You use your metal rule live, as you can see there on the screen, getting on your paper. The paper given to you is where you measure directly from. There is no other shortcut. It's just to measure that thing that was given to you. So we have to have the serial number. We will have from number 1, 2, 3, 4, and 5. Therefore, the raw, that's what is on the paper, actually is 6.1, multiplying by the scale, and this should be our simple pendulum. Write the question number. So if you multiply by 10, you get 61.0. Then the second y1, the raw, was 7.1, which will give you 71.0. Then the third one was actually 8.3. Yes, I've measured it already, and when you multiply, it gives you a 3.0. Then the fourth one was 99.4, of course. Multiply by 10 gives you 94.0. Then the fifth one, that's the length of the thread used to suspend the ball, is 10.6, which gives you 106.0. This is what you have to do. Then you follow the instruction which says TI. We go back and see what we are required to do in TI. So in the TI, TI is I'm going to measure. That's the time. Okay, of course, the TI is the corresponding time, which is also what I told you. So exactly, I'll feel what is here. For Y1, the T1 is 28.7. So we go back. So the time for each one, we have 28.7. It was given 28.7. The other one, you have I can divide the screen so that we'll compare them. Okay, the T2 we have 31.1 exactly. So we have 31.110. Then the next one, checking the reading here, that should be the T3, which should be 33.660. Remember to put the units, is already there, the column on top of the table. Then the next time is 36.1. Check well. 36.1, that's over here. Don't know. So we have our 36.10. The next one is 38.1. And then the period, which is actually time over number of oscillations, because the question says time taken for each of the length of the thread, the board is allowed to oscillate, that's to go to and fro for 20 times. So you are required to assess T divided by 20 for period for each one. So doing that, we have here already, we just need to do 28.7 divided by 20. You divide each unit here by 20. Each of these units will be divided by 20. So, and if you do that from the calculator department, you have 28.7 divided by 20. We'll get 28.7 divided by 20. We'll have 1.43, which should be 1.4 to the whole number. So over here should be 1.4. So continue the process. This should give you 0.20, 0.30, 0.25, 0.27. Then no, there's a mistake somewhere. I have to multiply correctly, please. 31.1 divided by 20. 31.1 divided by 20 is, so divide times in. It's 1.55, which is 1.6 on the approximate. So here should be 1.6. 1.6. And I think is increasing. It should be 1.7, 1.8, 1.9. Then the next, you are required to take log t. That's log of 1.4. So let's see log 1.4. 1.4 log, which will give you 0.14. So here should be 0.14. I did the same thing. So with this we will get 0.2, 0.23, and 0.23 again, the approximate, and 0.27, 0.27. Then you are required to take log L, which is taking the log over here. We have taken the log of these values. So let's check. Log 61 should be what? Log 61 is 61 log should be 1.785 for here. It should be 1.79. So here we have, let's get rid of our highlight. So here should be 1.79. Then log 71 is 3. Why this now? No. So 71 it's too high. 1.85. So we go back and fill 1.85. 0.85 here. The other one should be 1.91, 1.97, and then 2.02. So the next thing is to look at what the question requires you to do again. So we go back. They said after taking these values, they will tell you plots. They told us to plot a graph. Over here is the plot a graph with log t on the vertical axis and log L on the horizontal axis, then determine the slope of x. See it. Then you evaluate this value given to you, then taking the value of k as the intercept, you find it from that slope and from the graph you plotted. So that's it. Other questions is a theoretical question. Explain briefly how the frequency of oscillation of a simple pendulum is affected when its length is shortened. Using the graph, you deduce what is happening. As the length increases, what happens to the number, the time taken, and so on and so forth. So that's one thing you will answer there. But what matters is that this is alternative to practical. You just measure the real things you are told to measure, and that settles the case. These things, you measure them. The same thing is applicable to other questions, like here, question number 2, which should be on it should be on lights. You will also look at the instructions. So you just go there. You also measure. You measure y1. This one they also gave you scale x, that 1 cm is equal to 10 cm. So you have your raw and real as usual. Then you follow the instructions. After this, you get the other until you get the two variables that you plot. Why you make table and complete the whole table is because the last two variables are usually what you are required to plot in your graph. So we go back. Then you see the graph. After I finish plotting it, and that's how to do it in alternative to physics practical. It's all about being accurate with measurements. So going to the next question, like I showed you here, you see I'm measuring it. You see the raw, I'll multiply by 1. I'll multiply each cm by 10 and get the real, and each one has its own. Remember, from their drawing you can deduct what r is. The r is just the the distance between B and actually E. That's what they used as R there. So, and here they gave us scale here that 1 cm is equal to 2 cm. That's what we'll be multiplying in this second situation and make your table. So thanks for watching. Don't forget to subscribe and ask your questions in the comment box.
Hi, I wanted to tell you that you can contact Her Majesty Is World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty Is World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.